Hello everyone, this is INE Foundation Lab 2, Section 6.3 OSPF over DMVPN. Okay, let's check our topology here. We have DMVPN, Phase 2 DMVPN between R1, R8 and R7. R7 is all hub. They use tunnel 170 from R1 and R7. And there is another from R7 to R8. This is tunnel 78. This spoke and hub, and we have spoke. R1 is a spoke and R7 is a hub. This is the phase 2. Let's check. Let's first check. And also this tunnel, the tunnel interfaces are inside our VRF. We have VRF, black, VRF, DMVPN. This is VRF and VRF. Under VRF configuration. These are interfaces. Okay, this is show VRF. 7 is tunnel 17 and 78 under the DMVPN VRF. Tunnel 70 is under the DMVPN VRF on R1, and R8 is tunnel 78 on the DMVPN VRF. And let's check our tunnel showdown interface. Tunnel 78 and showdown interface tunnel 17. But this is hub. We have tunnel protection. Tunnel mode GI mode tap on hub. On the spoke we have tunnel mode GI multi-point and tunnel mode GI multi-point. It means it is DMVPN phase 2, and because we don't have this configuration, and because we don't have IPNH redirect on hub. On hub we don't have IPNH redirect, and on spokes we don't have IPNH shortcut. Then it is the DMVPN phase 2. This is the DMVPN phase 2. Okay, let me quick explain OSPF routing for DMVPN phases, then I will come back and conclude this section. Okay, let's just quick refresh the source OSPF routing. Okay, as we know, the next moving higher. Okay, there are 5 OSPF network types. OSPF network type point-to-point will not work for all DMVPN phases because it is point-to-point. It requires single circuit between two directly connected routers, and for the DMVPN on hub router, if I check on configuration on hub router, we have tunnel mode GRU multi-point. It means we have more than one interface for hub router. For this reason, OSPF network type will not work for all DMVPN phases. We have to forget about this network type for DMVPN. Point-to-point will not work. Let's check other network type. Let's start with DMVPN phase 1. Point-to-point will not work because it uses multiple interface and we need more than one interface for spokes on hub router. Let's check broadcast network type. Okay, in broadcast network type requires the broadcast and non-broadcast network type requires DR and BDR election. For this reason, we just to make sure that spoke routers will never be elected as DR or BDR. Okay, in broadcast network type, it will work for the DMVPN phase 1. It automatically establishes neighbor adjacency. It's okay. And because it is the DMVPN phase 1, we don't have direct spoke to spoke connectivity. It is okay. It is okay for the DMVPN phase 1. And because it requires the BDR election, we just to make sure that the spoke router will never become DR or BDR. By simply using this command IP OSPF priority 0 on the tunnel interface for all spokes. The OSPF broadcast network type will work for the DMVPN phase 1. It's okay, but we don't have direct spoke to spoke connectivity to the DMVPN phase 1 feature. Non-broadcast is the same as broadcast. It will work for the DMVPN phase 1, and in non-broadcast we don't have automatic neighbor discovery. For this reason, we have to configure neighbor command on a hub for each spoke. It is the same as broadcast. We just to add we just to configure neighbor spoke remote address for on our hub router for each spoke. We have this configuration plus we just to make sure that spoke router will never become DR or BDR by IP OSPF priority command on our spokes. This network type will work for phase 1. Okay, broadcast, non-broadcast will work. Let's check another network type, to point to multi-point. Okay, OSPF point to multi-point network type. Point to multi-point network type. We have automatic network discovery and we don't have the BDR election. For this reason, this point to multi-point network type it is best option for the DMVPN phase 1 because it will automatically establish neighbor adjacency. Traffic passes through the hub. It is the DMVPN feature, and there is no DRB direction, then we don't have to come to IP OSPF priority on a spoke. And because it is automatic neighbor discovery, then we don't have to configure neighbor command on each hop for each spokes. This is the best option for the DMVPN Phase 1. The point to multi-point is the best option for the DMVPN Phase 1 for OSPF configuration. Point to point is the same as point to point number is the same as point to multi-point, but because we don't have automatic neighbor discovery, then we have to configure neighbor command on hop for each spokes. This is this command, and this is this command. This point to multiple number will work for our DMVPN Phase 1. But the best option is this one. It requires little less configuration, and it is working. It will automatically establish neighbor addresses. Okay, let's check on the DMVPN Phase 2. Point to point will not work because it requires only one interface, but hop requires and we have MGI on hop. It will not work point to point. Broadcast, because let's check DMVPN phases. Let me check DMVPN. Okay, in this is not DMVPN. This says okay. Okay, for the DMVPN phase 2, a spoke router will reach out the spoke by sending an HRP to the hop. There is a requirement for for spoke-to-spoke communication or connectivity in the phase 2. The requirement is that a spoke router need to have the route for the network that they are trying to reach, and the next sub-IP address of the route has to be in the remote spoke. The requirement for direct spoke-to-spoke communication is this for RDMA phase 2. Okay, let's check OSPF the DMVPN phase 2 OSPF. Point to point will not work. Let's check broadcast. It will automatically establish neighbor adjacencies. And like as I said before, this is broadcast, and we just have to make sure spoke will never become DRBDR by this command. And each spoke router has in this broadcast network type, in the this network type for the DMVPN phase 2, each router has the route for other spoke router. Because this is a requirement for the DMVPN phase 2 direct spoke-to-spoke communication, we have direct spoke-to-spoke connectivity for this DMVPN phase 2 for this OSPF network type. This broadcast network type is the best option for the DMVPN phase 2. We have direct spoke-to-spoke connectivity, and we have automatic neighbor adjacency. But we have to make sure that spoke router will never become the DRBDR by IP OSPF priority 0 command on our spokes. Let's check another network type, non-broadcast. It is the same as broadcast, plus because we don't have automatic neighbor discovery, we have to configure neighbor. to use neighbor command for each spoken hop. And there is direct spoke-to-spoke connectivity because each spoke router has the routes for other spoke router on our spokes. But this broadcast is better, it has less configuration than non-broadcast. This is the best option. Okay, point to multi-point network for the DMVPN Phase 2. If we configure point to multi-point for on the DMVPN Phase 2, next IP for our export will become hop, and our spoke-to-spoke traffic will be sent to our hop router. Because it is the DMVPN Phase 2 and we want direct spoke-to-spoke connectivity, it is not a good option. Point-to-point is not a good option. Point-to-multi-point is not a good option for our DMVPN Phase 2. Point-to-point multi-point non-broadcast is the same as point-to-point. There is no direct spoke-to-spoke connectivity, plus we have to use neighbor command for each spoke on hop. These two options is not a good option. The best option is broadcast network for our DMVPN Phase 2. Okay, and let's check DMVPN Phase 3. Point-to-point will not work. Broadcast will work. Each spoke router has the route for other spoke routers. This is good. And there is direct spoke-to-spoke connectivity. And because we don't have, and because we have DR/BDR election, we have to make sure that spoke will never become DR and BDR by this command. Non-broadcast is the same as broadcast. Plus, because we don't have automatic neighbor discovery, we have to configure neighbor for each spoke on hop. And we have direct spoke-to-spoke connectivity, and each spoke router has a route for other spoke routers. Point-to-multi-point, this still is work. The point-to-multi-point is interesting. The next hop in point-to-multi-point network hop for the DMVPN Phase 3, the next hop IP address of route is hop IP address, and if we ping first ping will pass through hop, and our second ping will become directly connectivity. And we have this percent symbol in show IP route or show IP route OSPF, which means that the next hop is overwritten because of initial IP. Our second, after our first ping, we have direct spoke-to-spoke connectivity. This is also point-to-point, point-to-multi-point. Point-to-multi-point number is the same as point-to-multi-point. Because we don't have automatic neighbor discovery, we have to configure neighbor command for spokes on our hop router. And we have direct spoke-to-spoke connectivity, and we have this symbol for point-to-multi-point non-broadcast. Go for the DMVPN Phase 3. All we have direct spoke-to-spoke connectivity. This network type I think is best option for the DMVPN Phase 3. Okay, let's conclude this section. This is our OSPF configuration. Okay, Comco OSPF area 0 between R1, 7, 8 in the DMVPN network. Okay, this is because this tunnel is under VRF. Show VRF. Yeah. Okay, we can Comco OSPF either by network command or on the interface level. We can Comco OSPF. Okay, let's we Comco this on the interface level. The next go on R7. Just config T. First check routing protocol. Show IP protocol. Do show IP protocol. On 7, I don't have any routing protocol. It is only application. On R7 and R1, I have BGP, and I have only BGP is 100. On R8, okay, I already have OSPF process ID of 2, and that's it. Only OSPF process ID of 2 on R8. Okay, interface tunnel. Tunnel 17. Yes, into tunnel 17. Okay, if you know, I don't have any routing protocol, but if I can't go on the interface level, let me check. IP OSPF. Let's check. See, 100. This is not 2. And area, I have to come for area 0. And if I do show run pipe section water OSPF, I have water OSPF 100, and this is VRF DMVPN. This is because our tunnel is in, it is like address family, it's kind of address family, VRF DMVPN, because this tunnel interface is under VRF. Let's come for interface tunnel 78, same as I have to configure IP OSPF 100 area 0. Okay, let's do this. Go here, config T. This is interface tunnel 70 and IP OSPF 100. This is config T, interface tunnel 78 and IP OSPF. Okay, our OSPF neighborship is up. do show IP OSPF neighbor. This is full. And R8. So our tunnel. Let's check OSPF network type to show OSPF. Show OSPF interface tunnel 78. Which is tunnel 78 is up. The default OSPF type is point to point. There is no DRBI election and auto discovery. We have auto enable discovery and no OSPF neighbor command is. This is default OSPF network type. We are full and no DRBI election. Okay, now let's create new loopback. Loopback on R1 and on R8 respectively. Okay, let's create new loopback. And advertise them into OSPF. R1 interface loopback 1. Let's check what are the loopback. Do show IP interface brief. We have a loopback 0. Interface loopback IP add. Let's check. Okay, because our OSPF is VRF. Let me check into the VRF. Add this interface into VRF. VRF forwarding DMVPN. Then add IP address. IP address 11111111255. And I have to advertise into OSPF or interface level advertisement. This IP OSPF 100 0. Okay, if I do show IP OSPF do show output OSPF Okay, this is global. Put VRF, then DMVPN. I do show pre-root VRF. Okay, that's it. It should not work. On the VRF, I have advertised where it is. This loop back. This correct. So I loop back, and that's it. Okay, let's create on 8. Rotate config T, rotate interface loopback 88, add it into VRF, VRF forwarding DMVPN, then add IP address 8888 8888 and 255 and add that into OSPF, my IP OSPF plus ID area 0, and let's check show IP root VRF DMVPN, and let's check on root. We have advertised this, and I received this network via R1, which is advertised into OSPF. And if I check on R1 again, I will see root for 8. Okay, this is advertised, and R7 loopback should advertise into R7 loopback 0 should advertise into OSPF, but it should not be associated with any particular area. Okay, we have to make it will become type 7 for in our OSPF database. For this to happen, if whenever we redistribute, this is OSPF, whenever we redistribute the root, this distribute into OSPF, it will become type 7. Okay, let's redistribute this loopback. Let's check our loopback 7. Show IP interface brief. We have loopback 0. Config T. Interface. Okay, we have to add it into VRF. VIF forwarding DMVPN, and I have disabled it. I have to add an IP address. It's IP addresses. IP address 777.255.255.255.255. And now let's distributing to all OSPF. If I do show run pipe section rotate OSPF, oh yeah, what OSPF, you have to get distributing to this VIF DMVPN. Okay, please config T. If I do show IP OSPF, this ID1, okay, this is backbone. This backbone area. Number of interfaces 2 area has no authentication, and the area ranges are this one, and so on. It is an area border ABR. Okay, now let's config T. Route map. Let's say connected into DMVPN. Limit 5. And I have to match interface loopback 0. I have to create route map and match this interface loopback 0. And I have to go on the OSPF configuration, show run pipe section, go to OSPF. After that, do redistribute connected subnet, and that's a route map, and what is our route map name is this one, connected into the MVP. Okay, now let's check show IP OSPF. Now, because I have redistributed route into OSPF, it will become autonomous system boundary rotate. In previous configuration, it was it is an area border of the area, but because of where is this area? It is an area, and because of it distributed into OSPF. Where's this? It become autonomous system boundary code. Okay, whenever you on this is R1, this is R2, this is whenever you dispose it into OSPF, this router will become ASBR. We will have, let us say, type 5. Let's check OSPF database to show IP OSPF database. This is, let's say, type 5 for 777 and 7. And if I check root, I have this E2 SPF. Let's say top is plotted into another OSPF network is being generated by ASBR, and we have E1 or E2 entities in short OSPF database. And this is type 1, let's say, in databases. This is, let's say, type 1. Okay, let's configure this. And when complete, R1 R700 should be full reachability. Okay, I will check. Ensure that no one of what exchanges over the DMVPN are leaked into the DMVPN network. Okay, let's check other DMVPN OSPF network we have. We have OSPF on our 5. Show IP OSPF database, and we don't have these routes here. We don't have 1, 7, and 8. Good. Okay, we don't have. Let's check our connectivity plus reachability. Let's check OSPF ping. Okay, I have to ping with VRF ping. VRF DMVPN 777 is working. We have 11. It's working. And so this is correct. It's working. Let's check on our launch ping. VRF DMVPN. Yeah, it is 7. We have 1. We have 8. 88, and it is work. Let's check, show IP root VRF DMVPN, and we have 1, and this is a 7. This is unleashed. On 8 and R1 we have E2 for 7 because it is NSSA, because LSAT 5, and show IP OSPF, show IP root, show IP root VRF DMVPN, and OSPF. We have 7 for E2. And these routes are not linked into other OSPF network or other OSPF network. Okay, this is our section. This was our section. I hope you have enjoyed this video, and thank you for viewing.